Welcome back to CSP channel, Learn Easy Way of Physics. This is Chary, Physics faculty. What we discussed in the previous class, we derived some equations, some formulas. So in the previous class, we had discussed velocity of a wave on a string, that is V equal to under root of T by mu. V equal to under root of T by mu. Here T is a tension in the string, mu is linear density of the string, V is velocity of a wave on a string. And the next one is power transmitting along the string, that is P equal to of mu omega square A square, right? Velocity V. And another one is the intensity of the wave on a string, I equal to of rho omega square A square V. Here rho is density of the string, omega is angular velocity, A is amplitude, V is velocity of a wave on a string. Okay, now we discussed in the previous class. Watch my previous videos. If you are not watching my videos, go to search box in YouTube, type Chary Sir Physics. Okay, all the videos will come and see that videos. Try to understand all the concepts because of all are in sequence. So don't miss it sequence and follow my videos, subscribe, tap the bell icon for notifications. Now, okay, back to our class. Let me go to start the topic today, that is principle of superposition. Principle of superposition. Okay, if we have taken one of the string, suppose two persons holding the string at two ends, snap their hands, the two waves are moving or traveling along the string. Here is like this. When the two persons are holding the strings at two ends with their hands, when they are snapping this string, the waves are traveling along the string. The first wave is traveling from left to right, and the second wave is traveling from right to left. Okay, you are getting my point? There are two waves. They are created along the vibration of the strings. Okay, who is getting the vibrations of that string? There are two persons. Two persons are holding that string. When they are snapping with their hands, there are two waves are traveling along the string. They are moving. Their approaches to each other like this. The direction is from left to right, and its wave pulse direction is from right to left. These are two wave pulse. They are created by two persons. Now after some time, here is like this, here is like this. Okay, two waves are meet at the same time, right? And here is, this wave is ready to move. This wave is ready to move from left to right. This wave is ready to move from left to right, this wave is moves from right to left in this direction. And another one is, here is, this wave is already, it moves at left side like this and like this. Here the wave is moving in this direction from right to left, and this wave is moving from left to right like this. The position of the wave pulse along the string when snapping the persons, the waves are moving approaches to each other. So here is overlapping two waves. After overlapping, the direction of the waves along the string, which is one wave pulse is moving from left to right, ready to its moves directions right side for this wave pulse. And another wave pulse is, it is ready to moves after overlapping, okay, from right to left. Are you getting my point? So, right, next one is, here the two waves, is it not? They are moving opposite in directions. So, after overlapping, so what is the direction of the two waves? They are moving in opposite directions. Like, here is direction is like this, and this wave direction is like this. This wave direction is from left to right, and this wave direction is from right to left. After overlapping, they are dispatching along the string, they are moving in opposite directions like this. Here, in another way, suppose for example, or when the wave is traveling like this, one wave is created along the string after snapping by the two persons. Here is another wave is like this. At the left side, one wave pulse is created along the string by the person, and in another person, when he is snapping, the wave pulse is created like this shape here. So this wave pulse is moves like this, and this wave pulse is moves like this, right? And this wave pulse is along the string. This wave pulse is created below the string, and they are moving towards each other. Here they are moving towards each other, they are moving in opposite directions. Look here, and in the same way, after some time, after overlapping, what is the shape of these two strings? These are like this. Here is like this. It's moving. Its direction is like this. And again, after overlapping, here is ready to move. This wave is transmits. This wave is traveling along the string. It moves away from left to right. And this wave pulse is traveling along the string from right to left. Here is, after overlapping, receives these two waves, how they are moving along the string, you can see like this. Okay, now here is wave pulse is moving like this. The direction is changed. Here is, it moves away from left to right. It's okay, traveling along the string. Here is moving like this direction, and this wave is traveling along the string. It is away from left to right. Here is the positions. Now finally I can write it here. After dispatching, the shape of the waves are like this. Here is, it is traveling, and this wave pulse is traveling along the string in the directions. So what do we understand about these types of wave pulse after created by the two persons? Here is, they are moving, okay, along the strings, approaches each other after combinations. Okay, is it not? So after combinations, or after approaching each other, after overlapping each other, then they are dispatching from its center. So they are moving in opposite directions. So when they are combinations, here is the combinations, here is the overlapping. Okay, after overlapping, then they are ready to dispatch from its center along the string. Here is also, in another way, we have observed, okay, by created two wave pulse by the two persons. After snapping, the two waves are moving, okay, they are approaching each other. After combination, what is the shape of here wave? Like this. Then, so after overlapping or after combination of two waves, the position of these two waves, they are ready to move in opposite direction along the string. See here, after completion, after combinations, then again they are dispatching along the string. So the dispatching waves are moving in opposite directions like this. Here is, after overlapping, the resultant displacement of these waves, that is represented by y. So the first wave displacement is y1, the second wave pulse displacement is y2. Here is considered, right? Now here the wave displacement is y1, this wave displacement is y2, right? So the speed of these wave pulse will be same, do not change after overlapping or after combinations. Okay, then after dispatching, when they are moving in opposite directions, the shape of these pulse cannot be changed. Here, right, it is moving from left to right, and this wave pulse moves from right to left. By snapping two persons with their hands, but the shape of these two pulses depends on how they are snapping by their hands, like this also. Here is, okay, the displacement of this wave pulse or wave, that is y1, and the second wave pulse along the string, its displacement is taken as y2. So after combination, like this. Here, after combination, its center, the resultant displacement, that is y. The resultant displacement, it is y. The resultant displacement is y. So here the resultant displacement y, this displacement is y1, and this displacement of the wave is y2. So here y is equal to y1 plus y2. Here the resultant displacement of the wave, which is equal to the sum of individual displacements of the wave pulses, called as principle of superposition. Here is, here is y1 comma y2 our displacements. Y1 comma y2 are displacement at a particular time and position, at a particular time and position, due to individual displacements then the resultant displacement is given by here y equal to y1 plus y2. So this is principle of superposition. You know, here is y1 comma y2 are displacements at a particular time and position due to individual displacements. Then the resultant displacement is given by y equal to y1 plus y2. Simply we can say the definition of principle of superposition. The resultant displacement of the wave at a particular time and position, okay, which is equal to sum of individual displacements of the waves. So the equation is written here is y equal to y1 plus y2. That is called as principle of superposition. So the next one is position. Applications of principle of superposition. Principle of superposition. Wave. Interference of wave. And the second one is formation of stationary waves. Formation of stationary waves. Stationary waves. And third one is formation of beats. Formation of beats. Here, what are the applications of principle of superposition? Interference of waves. Interference of waves. Formation of stationary waves. Formation of beat. Adding two waves. Adding two waves differs in phase. If we want to take formation of these stationary waves, adding two waves differs in direction. Here is formation of beats. Adding two waves differs in frequency. Here is depends on frequency, here is depends on direction, here is depends on phase. Here interference of waves, when the two waves are adding, their difference represents phase, that is in phase. Now when the two waves are adding, they are differs in direction. Now when the two waves are adding, here is the waves differs in frequency. Adding two waves differs in phase, adding two waves differs in direction, adding two waves differs in frequency. Okay, is it not? These are applications of superposition. Write these points. If the first wave if the first wave is traveling along the string, then the displacement of wave function is given by here y is equals to, consider f1 of t minus x by v. Previously we discussed, we have derived this equation. We have written many times this equation. When the wave pulse or wave which is traveling along the positive x direction, the wave displacement function is given by y equal to f1 of t minus x by v. Now, if the second wave is traveling, along the string, then the displacement of wave function is given by here is y1 considered, here is y2, second wave, along the string. The first wave is traveling along the string from left to right, and the second wave is traveling along the string from right to left. We discussed just now. Again here the second wave displacement is considered y2 which is equal to, the function is f2 of t plus x by v, because of the wave is traveling along the string which is in negative x direction. We know already, we discussed previously, when the wave is traveling along the string which is moving along the negative x direction. Hence the displacement is given y2 equal to f2 of t plus x by v, because of when the first wave is moving forward direction and the second wave is moving in opposite direction of the first wave. So it is moving, second wave is moving in the negative x direction. The first wave is moving in the positive x direction. When it takes place, positive x direction, the wave displacement is mentioned here. And when the second wave is traveling along the negative x direction, because of it is an opposite direction of the first wave. That's why the wave displacement is given y2 is equal to f2 of t plus x by v. Now, according to principle of superposition, we know the formula. Do you know the formula? Yes, we know. So the formula is according to principle of superposition. Principle of superposition. Principle of superposition. Y equal to y1 plus y2. The resultant wave displacement which is equal to sum of individual displacements. That is called as principle of superposition. Now we know the equation, the first wave displacements. Okay, both equations we have to substitute in that equation. Y equal to, that is, what is y1? You know, f1 of, here is f1 of t minus x by v plus, next one, y2 displacement. We have written now equation. That equation we can write it in that place. f2 of t plus x by v. This is the resultant wave displacement, f1 of t minus x by v plus f2 of t plus x by v. This is the resultant wave displacement. So the next topic is interference. Interference of wave going in same direction. So what is interference? Combination of two waves in the medium. It is called as interference. But the interference are two types. The first one is constructive interference. And the second one is destructive interference. Like this. Here is constructive interference means there are two waves which are moving in the same direction after combination. That type of combination is called constructive interference. Like this. Here is like this. One wave is traveling along this string. It is moving in the positive x direction, and the next one is also, next wave is traveling, okay, with the same phase. It is moving with the same phase. So the resultant is indicated here. The resultant is indicated here, this one. So here is, this wave is y1 and this wave displacement is y2. The resultant displacement is y here, like this. There are two waves are combination. They are moving in the same direction, okay, after combinations. This type of interference is called constructive interference. Here is when we have taken the individual displacements, the first wave displacement is considered y1, the second wave displacement is considered here y2. So how should be indicated the resultant wave displacement? Here is mentioned. This is the resultant wave displacement according to the principle of superposition. So how we can write the wave displacement equation? Y equal to y1 plus y2, principle of superposition, that is, okay, y equal to y1 plus y2. So this is called as constructive interference, and the destructive interference is nothing but, so when the two waves are moving in opposite direction after combinations, like when they are moving like that, the stationary waves are formed, okay, like this. First wave is transmits like this, second wave. So first wave in the direction is like this, here like this. Okay, now this is the first wave, this is second wave, and the second wave is moving like this. Okay, the first wave is moving in this direction. So here is the displacement is y1 and the second wave displacement is y2. Here the resultant displacement is mentioned like this. Here is moving like this. So this is represents resultant wave displacement. If any two waves are combination, they are moving in opposite directions. Okay, at the time of, here is, okay, the pulses are, when the pulses are combination like this, here is, okay, number of pulses are combination of like this, here is formed. The individual displacements are mentioned, y1 and y2. The resultant wave displacement after combination is represented capital Y. According to principle of superpositions, what we can write the formula? Y equal to y1 plus y2. At a given point, two waves arrives with the phase pi, then the equations are given by two waves arrives at a point O. Its amplitude is A1, its amplitude is A2. Here is the resultant amplitude is A with the phase is pi, which makes an angle of theta here. So what are the equations? y1 equal to the wave displacement, the first wave displacement wave equation is given by y1 equal to a1 sine omega t, and the next second wave displacement equation can be written as y2 equal to a2 sine omega t with phase pi. This is equation 1 and this is equation 2. Here is according to principle of superposition. Principle of superposition. Principle of superposition. Here y is equal to y1 plus y2. The resultant displacement equal to sum of individual displacement, that is called as principle of superposition. We know the displacement equations. These we can substitute it in that equation. Y equal to, what is y1? a1 sine omega t plus y2. What is y2? a2 sine omega t plus pi. So here is a1 sine omega t plus a2 sine omega t plus pi. It is in the form of sine a plus b. What is the formula of sine a plus b? Sine a cos b plus cos a sine b. Okay, we can write in the form of sine a cos b plus cos a sine b. Right. a2 sine omega t. First a2 sine omega t cos pi plus next a2 cos omega t sine pi. Here is sine pi. a2 sine omega t cos pi plus a2 cos omega t sine pi. Here is equal to a1 sine omega t. Here is a1 sine omega t. Here is also a2 sine omega t. So sine omega t we are taking common. Sine omega t common. The remaining a1 plus a2 cos pi. So plus here is taking common sine omega t of a1 plus a2 cos pi plus here a2 cos omega t sine pi is there. a2 cos pi, a2 cos omega t sine pi. Here that is equal to a1 plus a2 cos pi, a1 plus a2 cos pi. Let we are taking a1 plus a2 cos pi, which is equal to, here consider a cos theta. Here next a2 sin pi. a2 sin pi we considered a sine theta. This is fourth equation or third. Okay, this is third equation and this is fourth equation. Here is equation third and fourth. Squaring and adding. Squaring and adding. Adding on both sides. On both sides. Squaring and adding on both sides. Here is a1 plus a2 cos pi whole square plus a2 sin pi whole square equal to a cos theta. A cos theta whole square plus a sin theta whole square. It is in the form of a plus b whole square. So we can write a1 square plus a2 square cos square pi plus 2a1 a2 cos pi. So plus a2 sin pi whole square, a2 square sin square pi equal to a square cos square theta plus a square sin square theta. Here is a1 square plus a2 square cos square pi. a2 square cos square pi we can write here plus a2 square sin square pi plus 2a1 a2 cos pi. Here that is equal to a square cos square theta plus a square sin square theta. Here is a1 square plus a2 square common, cos square pi plus sin square pi plus 2a1 a2 cos pi, that is equal to a square. A square is common, cos square theta plus sin square theta. So its value is 1. The remaining a1 square plus a2 square cos square pi plus sin square pi value is 1. Here is plus 2a1 a2 cos pi equal to a square. Here cos square theta plus sin square theta value is 1. So only a square. Here is right in order. A square is equal to a1 square plus a2 square plus 2a1 a2 cos pi. Now a is equal to under root a1 square plus a2 square plus 2a1 a2 cos pi. It is the magnitude, resultant magnitude of the amplitude of the wave. A equal to under root of a1 square plus a2 square plus 2a1 a2 cos pi. But the intensity of wave, which is directly proportional to square of the amplitude, but I is directly proportional to a square. Here is this relation can be written as I1 by I2 equal to A1 square by A2 square. A2 square. Now here is I is equals to ka square. If k value is 1, we can write it 1 into a square. So that I is equal to a square. So where the a1 we can write it I1. Where the a2 we can write it I2. So here is, because of I is equal to a square, no? So here is a square from this equation. So from equation a square is equal to a1 square plus a2 square plus 2a1 a2 cos phi. So from this equation a square, here I is equal to a square, but a square equal to I, no? I, that is equal to a1 square I1 a2 square I2 plus 2 root I1 I2, here is cos phi. This is intensity of the wave. So here is I equal to I1 plus I2 plus 2 root of I1 I2 cos phi. Cos phi right in outside.